30.6 volts. Maximum power voltage that you can get is 24.5 volts. 24 volts, you have a tiny little bulb for 24 volts in here. Okay, you can operate it. You stick right across these leads up here. You shine some light up here outside in your beach house in Florida up there, or thing up there. Now what happens is you're lighting up that bulb up here. Let's not get into the inverters, because the inverters is actually what the function of the inverter is. The function inverter is taking what? A certain type of what? Voltage and changing from AC to DC. Hold on to your question until we get into that. Okay. There is to a certain point. You can't put like 1 volt in and do the conversion. Okay. The inverters are rating for the actually rate, you know, of operation from what range to what range, and there are many different ones. Okay. But from a standalone system, for a DC type of system, you can do that. Key things in here. You had a question, sir?
Yeah, I just wanted to say, so you're saying that if, let's say we're mounted on one breaks, you want to go to a local supply house, the way you would match it is you would look at the name tag to make sure maximum open voltage and short circuit current is the same. That's
right.
How you would match it.
And power dissipation. The key thing is you want to change it exactly with the same kind of characteristics. The same kind of characteristics. So usually what you do is you get the same module number. If not, what else? It's gonna, you know, if you get one that is slightly different, so you're really gonna matter. A little bit. Okay? A little bit gonna matter. But if the range is a lot, then you just, what I'm trying to say, you just can't just get whatever you find there. It's not like you're changing, you know, a 3/4 horsepower motor, you put a 1 horsepower motor up there, it's doing the job, you know what I'm saying? When you, and again, this repeats exactly what I said, when you put the circuits in parallel, the current is what? The sum of individual devices or the strings, and the voltage still remains the same. And again, the overall current voltage characteristics of these devices in parallel, again, and depend again on the similarity of the current outputs of the individual in here. Here's what happens if the devices in parallel. This is the first one, this is the second one, the combination of the both. If you have the similar ones, what's going to happen in here, you're going to have the average of the two of them. So you like to have them at the same voltage and current characteristics as possible, or exactly the same. There's variation for that. Their ranges there come all the way from different types of sizes. You have smaller modules for 5 watts, 20 watts. I don't know if you have a smaller one floating around here. I don't know how many watts that thing is. Most of the stuff of the smaller ones, they use what? For small, low battery types of charging applications. One of the things considered that some of the smaller modules, they're going to be what? More expensive per unit. Watt output are the largest ones. And usually you don't use those small ones to build big arrays and so forth. Different sizes and shapes, all the way from square, rectangles, triangles, flexible. You know, there's some areas, spots in a roof and so forth, that you may have to fill it in with an array to comply with the requirements, and you may have to use different actually modifications of the panels. Not all of them are like that shape. Okay, and now the module bypass diode. You remember before we talked about the bypass. What is that thing is used for? It's a device. It's actually, most of you have seen it with the bypass diodes. And it's actually used to bypass current around rather through the group of the cells, okay? If you have an open circuit or a high resistance up here, what's going to happen to the panel? What's going to happen to the panel if you have an open circuit? It's going to stop. So what's going to stop, or what happens if you have a panel that is open? You're going to lose the whole string. So we still want to find out that if we have a string of panels that is hooked up in series, okay, or in parallel, that even though I lose one of those modules, I still have some method of what? Still delivering some power, but it's some power loss, okay? And if I look it through here in a little diagram in here, this is what happens in here. That I have these cells in here. This is the bypass diodes in here, and what's a diode? What happens is it conducts what? Current in only what? One direction, okay? And they used a lot as a switch, okay? So what happens in the normal condition, the current goes around through the cells. Now over here, all of a sudden you have what? A shaded condition, or the thing opens up, the current is going to flow through here, it's going to come to this here, and it's going to continue to flow through it. So now I'm going to lose what? The operation for this particular. So therefore the power in here is going to be what? Since this thing is going to be eliminated, now what's going to happen is I have a lot less of a power. So the bypass diodes allow current to flow around these devices that develop what? Either an open circuit condition here or a very high resistance condition here. What is it? They have them in the panel. Yeah. Some of the older panels, I think you had to put them, if I'm not mistaken. Some of the older panels, the new ones, I think they have them all in there. The factory installs them, yeah, they have bypass diodes here. Most of the new ones in here, the old ones, I think you saw the other ones they had installed. Sometimes of the very, very old ones, you had to go and put them back there yourself. If you don't have those bypass, guys, it's a very important thing about the bypass diodes, and sometimes you open the junction and you check them up there to see if there's any problems. Sometimes if you can get to that panel, to that module up here, after you do some troubleshooting on it, and you say this is it, you check actually you don't take the panel because you don't want to spend $500-600 up there. You want to make sure that there's any problem associated with the panel. Of course, depending what side of the roof it is, you don't want to stick your head underneath finding out. So when you do troubleshooting, it's one of the things that you have to know about this stuff well, and also to be able to troubleshoot it. So there's several things. If you don't have a bypass diode, you're going to have what's called reverse voltage up here, and decrease the voltage until you're reaching what's called a breakdown voltage. And what that is, the breakdown voltage is usually the minimum reverse bias voltage, and you can increase through the current and you can destroy the panel itself. If I look, okay, and you're going to have, actually, if you don't have the bypass diodes, you're going to create what? An excessive amount of what? Current, and you're going to destroy the module itself. Typically, what it does is has a certain voltage level that allows you, what it does is bypasses. What in practical application, it just makes the current going around the module without dying, killing it up here, okay? So, I don't want to lose you in this one, but typically if this is your open circuit voltage, if you plot your current and the voltage, if this is your open circuit, and if you're operating of the panel here, and this is the device is operating properly. If you don't have, with a bypass diode, this one does what? Limits the actually current in here. If you don't have that, and the bypass, you go on what's called a reverse voltage, and this built in here, and what happens is an increase in current is going to burn the device. If this, with the bypass diode, is what? It's set at a certain voltage level, the little device in here, it's like a little switchy here, and actually what it does is actually allows the current to go around it